Hi everyone, today we are going to discuss determinants and the multiplicative inverses of matrices. Okay, so to get started, every square matrix has a determinant. Okay, so a square matrix meaning a 2 by 2, 3 by 3, 4 by 4, all that good stuff. Okay, so in order to find the determinant, we are going to multiply these two values together and then these two values together and then subtract them. Okay. So let's go ahead and do some practice here. We have 8 times 6 minus 7 times 4. So 8 times 6 minus 7 times 4, or 4 times 7, doesn't matter, right? So we get 48 minus 28, which is 20. Okay? All right, number 2, we're going to do 0 times negative 6 minus 8 times negative 2. Okay, so we have 0 plus 16, which equals 16. All right, and remember this becomes a positive because we have two negatives there, okay? All right, anything that is larger than a 2 by 2 matrix, we will do on the calculator. So to enter the matrix into the calculator, you first need to remember which one you name the matrix in your calculator. But let's go ahead and do that. So turn on your calculator, and you're going to hit second matrix right here. It's this button, the little X to the negative first. It says matrix above there, okay? And you want to scroll over to edit, and I'm going to label this as matrix A. So, and the reason why you want to be on the edit screen is so you can type in the 3 by 3 matrix, okay? And then type in your numbers, -4, -6, 2, 5, -1, 3, -2, 4, -3. I always double check to make sure I type this all in correctly, because one little negative sign or one number that's incorrect will mess up the whole problem. So now I'm going to go back to my main screen, so second mode, or second quit, okay? And to find the determinant of this 3 by 3 matrix, I'm going to hit second matrix, go over to math, and one determinant, DET, will give you the determinant of the matrices, of the matrix. So now I got to type in the name of my matrix, so second matrix, and I'm going to use this name column, and I want A because that's the one I typed it into. And it gives me 18. Perfect. Okay? So that's how you do that on your calculator. Go back and rewatch those steps if you need any help with it, okay? All right, every square matrix has an inverse except when the determinant equals 0. So to find the inverse of a matrix, say if we have matrix A is this guy right here, then to find its inverse, this is the notation for inverse, you're going to do 1 divided by the determinant. Notice that's the same notation up here. It looks like it's like in absolute values, okay? So that means you're going to find the determinant, and you're going to multiply it by, notice how A1 and B2 switch spots here? See how they kind of swap compared to the original matrix, okay? And then notice B1 and A2 stay the same. You just change the signs on them. So just be careful with that, okay? And so you would do 1 divided by the determinant and multiply it by these changes of the matrix, okay? So let's use the definition of the inverse of a matrix to find the inverse. All right, so to get started, we first need to find the determinant. This is a 2 by 2 matrix, so we are going to do this one by hand. So 2 times 1 minus 4 times -3, or -3 times 4, it doesn't really matter. All right, so we get 2 minus, that's 12, so positive 12, which equals 14. That's the determinant. So my inverse, I'm just going to label this as matrix A, okay, is going to be 1 over the determinant of 14 times, I'm actually just going to do this. We're going to multiply it. We're going to switch the 2 and the 1. So I got a 1 and a 2 there now. Those switch spots. And then I have to change the signs of these guys right here. So this becomes positive 3 and negative 4. All right, that's your setup. And then this is just scalar multiplication. So you're going to take this 1/14 and multiply it to each entry in the matrix. So we get 1 over 14, 3 over 14, negative 4 over 14 would reduce to negative 2 over 7. And then 2 over 14 would reduce to 1/7. And that would be your final answer. Okay? Alrighty. Now let's just do this little side problem here. So it says find A times the inverse of A. So this was matrix A. I labeled this as matrix A. All right. So we're going to, so that's 2, 4, negative 3, 1. And we're going to multiply that by the inverse, which is this guy right here. So I'm just copying it down. Okay. And we're actually going to type this in on our calculator. Okay, I want to show you how to do this on the calculator. So first we need to go type in these matrices. So I'm going to go over to edit. You have to go over to edit in order to type in the matrix. A lot of kids will stay here and try to do it here, but notice you can't type it in. So second matrix, go over to edit. So we have a 2 by 2. I've got 2, negative 3, 4, 1. 2, negative 3, 4, 1. Good. I'm going to go second matrix, and I'm going to type, oh, actually, that's all I have to do right there. Okay, so to type this in now, I'm going to do second matrix, and I want matrix A, and I'm going to multiply that by second matrix, matrix A, but the inverse of that, this button right here, okay, see that how like this A has a little negative 1 exponent? That's this guy right here. So you click that button, and there you go. All right, so you don't even have to type this in for matrix B or anything like that. You can just do your calculator knows what the inverse is. Okay, so we've got 1, 0, 0, 1. We're going to talk about what that is on the back. So the result that you just got in that last problem, that's called the identity matrix for multiplication. This consists of only 1s and 0s, where the 1s are the diagonal from the upper left to the lower right, just like this guy right here. See how the 1s start in the upper left and move to the lower right, and then everything else is 0? That's the same thing right here. Okay? So the multiplicative inverse also exists for some matrices. The inverse of a matrix we talked about right there. Anytime that you guys have a matrix and you multiply it by its inverse, it will equal the identity matrix, okay? So if it doesn't, then probably something wacky happened, all right? So let's find the inverse of each of these. In order to do that, remember it's this little formula right here, okay? This is the inverse of a matrix. So you have to do 1 over the determinant. So let's find the determinant here. So 2 times 0 minus 0 times 1. So I get, oh wait, no, oops. 0 minus 0, there we go, is 0, okay? So I'm going to go set this up. I have 1 over 0. I'm going to multiply that by this guy right here. Now, notice though, anything divided by 0 is undefined, right? So this inverse is not going to exist. There's no point for me to even write that out because it's not going to work out because you have 0 in the denominator. So this would indicate that the inverse does not exist, okay? And that's why on the front of the notes, it says every square matrix has an inverse except when the determinant equals 0. It's because 1 divided by 0 is undefined. Okay? So you see how that plays a role now there? All right, let's move on to number 7. So again, we do need to find the determinant before we can get started. So 8 times -1 minus 9 times 3. So -8 minus 27, which is, oh my goodness, I can't think, -35. There we go. Okay? So I've got 1 over -35, or -1 over 35, doesn't matter, times, remember these switch spots, so -1, 8, okay, and then these two change signs, so -3, -9, okay, and then we just multiply that, scalar multiplication. 2 negatives make a positive, so 1 over 35, 9 over 35, that does not reduce, positive 3 over 35, again does not reduce, and -8 over 35. Okay, none of those reduce, so that's it. You are done there. Okay, so we're just practicing finding the inverse on those problems. All right, now we're going to use the graphing calculator to help with the matrices that are larger than 2 by 2. So here we have a 3 by 3 matrix. So I'm going to show you how to do all of this on the calculator, like how to find the inverse. So you don't have to find the determinant or anything. We're just going to do it on the calculator. So we're going to go to, oh whoops, let me move that up a little bit. Second matrix. I'm going to go over to edit, and I'm going to make this a 3 by 3 again. 1, -3, -2, 0, 3, 0, 1, 5, 1. Perfect. Okay. So, all right, now we are going to find the inverse of that. So I labeled this as A in my calculator. So the inverse of A is going to be second matrix. Remember, you can just use matrix A, and then you literally just hit this button right here, x to the negative first. All right, now, do not write this as your answer on a test, okay, or quiz, or any of your homework assignments, all right? Change these into fractions, so we're going to hit math frac, and then that's going to be the matrix that you will give us, okay? So I've got 1/3, 0, -1/3. -7/9, 1/3, -8/9, 2/3, 0, and 1/3. There is your matrix, your inverse matrix. All right, so on your calculator, that inverse button, remember, is just right there. Okay? Alrighty. Go ahead and get started on your homework. Let your teacher know if you have any questions. Good luck.